All right, we're going to get started with lecture 22. This one's going to be on linear regression. I'm going to go over the notes, and then we're going to talk about how to do linear regressions. All right, so this week we're going to be using Desmos graphing calculator a whole lot. And that's because we're going to be graphing. So let's first go over the definition of linear regression. And if you missed this, this will be under notes under Monday in week 12. Okay, so regression is a statistical process. So we are going to be doing statistics this week. It is the statistical process for estimating relationships. Estimating relationships between what? Between a dependent variable, a dependent variable, that's going to be yi. Y is typically the dependent variable. And we're going to be comparing and contrasting that with the independent variable. So one or more independent variables. And the independent variable is going to be xi. So if you remember, x always comes first, so we're going to call that the independent variable. And whenever we do an ordered pair, y is going to come second. And y is always going to depend on what x is. So that's why we call y the dependent variable. All right, so the regression formula is what I want to talk about next. Regression formula. So when we do the regression formula, it's going to be yi is equal to f, where f is going to be a function of one or more independent variables. We call that xi. And then we're going to put a comma and then the Greek letter beta. That's not a b, that's going to be beta. We're going to close that up, and then we're going to add ei to it. So yi is the dependent variable. F is going to be some function. The function might be linear, or it may be nonlinear. And then xi is going to be the independent variable. Xi is going to be the independent variable. The beta is going to be the unknown parameters. Once we do the regression, it'll tell you what the beta is going to be. So it's not going to be a mystery to you. And the EI are going to be the error terms. So the regression it's not going to be perfect. So you're going to have what's called error terms. And the error could be big, it could be small, depending on what the regression is. But sometimes we call those error terms residuals. And that's what you're going to see on Desmos today. So this is the regression formula, and we're going to be using this for the whole week. Now, we do have an I at the end of a lot of stuff, and the I is just going to be an index. It's going to usually go between 1 and n. So I is going to go between 1 and n. N is going to be the number of variables we have. So we could have x1, x2, x3, x4, all the way up to xn. And the same thing with the y. That has a subscript of I as well. So y can range between 1 and n. So you can have y1, y2, y3, all the way up to yn. And then the ei is the last term that's going to have an I with it. And that also ranges between 1 and n. And the ei is always going to match up with the xi, yi. So that's the regression formula. Okay, so typically when you're doing regression, there's going to be a measure of correlation, and that correlation coefficient is going to be R. And once you do the regression on Desmos, it'll tell you what R is going to be. So the correlation coefficient is going to be R. And basically what that does is it's going to measure the correlation between two variables. It's going to measure the correlation between two sets of data. And typically it's going to be xi and yi. So there's going to be an R value, and the R is going to range between -1 and +1. So it's going to be between those two numbers right there. Now, if you square R, you're going to get the determination coefficient. So the determination coefficient is going to be R squared. You can write that as a lowercase r squared, or you could do an uppercase R squared. Whichever one, doesn't matter. This is going to measure how close the data is to the regression line. Now, since we're squaring R, if you square a 1, you'll get 1. If you square a -1, you'll get a +1. And if you square 0, 0 times 0 is going to give you 0. So the R squared is going to range between 0 and +1. So the 0, if your R squared value is 0, that means that there is no correlation. No correlation between the two sets of data. But if your R squared value is 1, that means that there is a perfect correlation. And the closer and closer that you get to 1, the better the regression is going to be for the two sets of data. So that's going to be what R and R squared is going to be. And again, once you do this on Desmos, it'll tell you automatically what the R value is and what the R squared value is going to be. So now there are two types of correlation. There's going to be a positive correlation This is when the slope of the regression line is going to be positive. So the slope of the regression line is positive. And we say R is greater than 0 when we do that. So what this means is when you have your scatter plots, you're going to have a bunch of dots, and the line that goes through them is going to be a positive slope line. So that's going to be a positive correlation. But then you have what's called a negative correlation. Negative correlation is when the slope of your regression line is negative. So when that happens, R is going to be less than 0. So let me draw you a picture of what this is going to look like. So here, your scatter plot may look like this. So the line that best fits the scatter plot is going to have a slope that's negative. So instead of going up as you go from left to right, the regression line is going down as you go from left to right. Okay? And then you're going to have a third type that I didn't put on the notes, but the third type is no correlation. So when you have no correlation, it's going to look like this. You're going to have a bunch of random dots, and there's no line of best fit that would go through and fit all of these dots. So this would be no correlation. So now let's talk about the strength of the correlation, because your correlation may be very strong or it could be very weak. And the way we categorize that is based on what the R value is. So if the absolute value of R is less than, let's say, 0.3, then the correlation is either no correlation or it's a very weak correlation. And then if your R value is between 0.3 and 0.5, I think I put in the notes, we call that a weak correlation. If it's between 0.5 and 0.7, we say that that is kind of in between. So we say that's moderate. It'll have a moderate correlation. And then if your R value, the absolute value of R is greater than 0.7, we say that is a strong correlation. Strong or very strong. So that's going to be the strength of the correlation. Okay, now based on what our function is, whatever f is, the function could be linear, or it could be a nonlinear function. We'll look at linear today, and we'll look at some basic types of nonlinear functions on Wednesday, next time we meet. But a linear regression is going to have its own equation. You've probably seen it before if you took Algebra 1. It's going to be y1 regressed against mx1 plus b. So this is what's known as slope-intercept form. Slope-intercept form. And the reason why we call that is because this letter M right here is going to be the slope. So M is going to stand for the slope of the line. And the letter B is going to stand for the y-intercept. And again, if you took Algebra 1, you already know about slope-intercept form. So I don't need to go really too deep into that. Just to let you know that any line, any non-vertical line can be put in the slope-intercept form. So that is the basic form of a linear regression. Okay, so what I want to do now is I want to go over to Desmos and show you how a linear regression is done there. So I want everybody in the class right now, yes, I'm talking to you, go ahead and go to Desmos. It's gonna look like this. I'm gonna resize my window so everything will fit there. There we go. And then I'm gonna bring this up. And perfect. Okay, so here I am at Desmos. You don't have to sign in if you don't want to, although that'll probably make it easier. What we want to do is we want to start off at the very top of the screen. So at the very top, the top left-hand corner, you will see a button with a plus sign on it. Way up here at the top left, it'll say Add Item. We're going to click that. And once we click that, we'll get 5 different options. The first one will be a function or an expression. And then the next one is a note. But we're going to click on Table. It'll say Table, and it'll have a picture of a table right next to it. Go ahead and click on that. And then a table will pop up. So on the left side of the table, you'll see x1. That's going to be our x values. And then over here on the right side, you'll see y1. It'll have an icon next to it with a bunch of dots. That's going to be our dependent variable. So go ahead and type in the numbers that I'm about to type in. Under x, we're going to do 1. And then we're going to hit the enter button. And then it'll give you another row. We're going to type in 2, 3, 4, 5, and 6. We're going to stop at 6. Those are going to be our x values, or our independent variables, as we call them. Now for our y values, we're going to have 1.5, 1.5. The next one is going to be a 3. And then a 4.5. 5.8. 7.9. Whoops. And then our last number is going to be 8.9. So once you put all those numbers in for the y values, it's going to automatically generate a graph of points. And your points might be different colors than mine are, but they should still be points and they should still be in the same spots that mine are. And what you can do is on the right side over here, you can see the plus button and the minus button. Those will let you zoom in and zoom out. So I'm going to zoom out until I can see all the dots nicely in a row like this. And then what you can do is you can click on this dot that's next to the Y1 up here. It'll make them disappear. And then you can click it again to make them reappear. And if you hold down on this little icon right here, it'll let you drag the points if you want to drag them. We're not going to do that. We could change the color of the points, which I'm going to do. I'm going to make them blue. So you can change the color if you want to. And up here, you can make them open dots, which we don't want. We want them to be closed dots. So make sure you've got them closed. So now what we're going to do is we're going to hit the plus button on this magnifying glass right here. At the very bottom of box 1, you'll see this magnifying glass right here that says zoom fit. We're going to click on that. And it's going to zoom in on however many dots that you have. So go ahead and click on that magnifying glass, and that's called zoom fit. Okay, so the next thing that we're going to do is we're going to click into box number 2 right here. See how there's a box under it that says box 2? We're going to click in that. And we're going to type in our regression equation. So we need a y1. I'm going to click on this y down here. See where it says x and y and a squared and a to the b power. We're going to click on the y. And then we're going to click on the number 1. So now it'll say y with a 1 at the very bottom of it. That'll be a subscript of 1. And then what we need is we need the regression symbol. I always call it a squiggle. So the way that you find it is we're going to click on the capital ABC at the bottom right here. We're going to click on where it says ABC. And then on the bottom row, you'll see the squiggle. We're going to click on this right here. And then a squiggly line is going to show up right next to the Y1. And it's very important that you have a 1 next to the Y. Okay? So now we need an M. You can type in an M on your keyboard, or you can click the M right here. Same thing. And we need an X1. So I'm going to go back to my regular keypad, and there's going to be an X next to the Y. I'm going to click on that X, and then I need a 1 next to the X. So I'm going to click on 1. And then you'll see how it says MX1. And then we're going to add B to it. So over here where it says all the numbers, see the plus at the bottom? We're going to click that plus, and then we need the letter B. So I'm going to go to ABC down here, and I'm going to click on the letter B, lowercase b. That's going to be my y-intercept. Okay. So once you put in the slope-intercept form of a line, y1 squiggle, m x1 plus b, this means that y1 is going to be regressed against m x1 plus b. And what we're going to do is we're going to write down all the information that it gives us. So if you look here in this box, it's going to say statistics, and it's going to give you the R value. We're going to write that down first, and we're going to write down all the decimals. So you're going to write down R equals 0.9975, and then you're going to write down the R squared value, the 0.9949. Go ahead and write that down on your notes. So the R is going to be your correlation coefficient. Notice that it's really, really close to 1. And what that means is our regression line fits the points very well. And then the R squared value is going to be the determination coefficient. And it's also going to measure correlation and how well suited the line is to our data. Now, the next two numbers that we're going to write down are our unknown parameters, right? Our beta. We have our slope at the bottom. That's going to be the lowercase m. M stands for slope. We're going to write down this number right here, 1.51429. That's going to be the slope of the line that you see. And then we're going to write down our b value. Our b is going to be negative 0.0333333. Go ahead and write that down. That's going to be the y-intercept. So that's where it crosses the y-axis. And you want to write down all the digits that it tells you, because the more digits that you write down, the more precise your line is going to be. Okay, so after you're done writing down those numbers, we're going to hit the plot button that's next to the E1. You'll notice that it says residuals right here. And E1 is going to be our error terms. It's going to measure how big the error is going to be in our regression. So go ahead and click the plot button. And these black dots are going to show up pretty close to the x-axis, which means our error isn't really that much. It's very, very small. And you'll notice that the error dot is right below the dots for our data. So this one is right below that one, this one's below that one. And the first three error terms are super small. And what you'll see on the chart up here is that the E1 column is going to contain our error terms. The first three numbers are really, really small decimals. So the error is almost 0, which is good. And then the next three error terms are a little bit bigger. So they're going to deviate a little bit from the x-axis. So what that means is our three data points at the bottom are not so closely tied to the regression line. So these blue dots up here, they're a little bit farther away from the regression line than these three dots right here. So obviously their error term is going to be much bigger. Okay. So the next thing we're going to do is we're going to click into box number 3. Box number 3 down here. And we're going to type in our regression line. Now we're going to be using f of x. So I'm going to need f of x. And we're going to have it equal to mx plus b. So I need my m value, which is 1.51429. That's the slope. We're going to put an x beside that. And then we're going to subtract our b value, which is 0.0333333. And this line should be a different color than what our regression line is going to be. But they're actually going to be the same line, because all we're doing is we're copying down the m value that it gives us and the b value that it gives us. Okay, so now once you've got that, I want to predict what's going to happen when x is 10. So in our chart up here, we have all of our x values from 1 to 6. But I want to predict what y is going to be when x is 10. So the way we do that is we're going to click into box 4 down here, and we're going to type in f of 10. And I'm going to close up the parentheses just like you see up there. And then at the bottom of the box, it's going to give me the answer, 15.1095667. So that is what the y value would be if our x value was actually 10. So we can continue this chart all the way down to 10, and then beside 10, the y value would be 15.1, let's say, if we round it to the nearest 10th decimal point. So that way you can predict what the y values are going to be in the chart with your regression line. Okay, that is linear regression. So now that we're done with that, we're going to click on the x's inside every single box. We're going to delete this first box, the second one, the third one, and the fourth one. So now they're all gone. Okay, so now go ahead and try the problem set and the classwork. We're going to be looking at the problem set next.